Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faisal Kabir Mat Syarudin, and I am with my friends Muhammad Syafiq Adli bin Azmi. Okay, now we want to present about CHM231 report, which is paper chromatography experiment. This is our presentation outline. First, we have objective. Second, procedure. Third, result and discussion. Fourth is conclusion. Okay, next is objective. In this experiment, we will observe black ink consists of other pigments and how different pigments in black ink separate based on their solubility. Capillary action allows solvent to travel up the paper, and different pigments in black ink will separate based on their solubility. Pigment that is more soluble in polar solvent will travel up the paper along with the solvent, but pigments that are less soluble in polar solvent will travel more slowly because of their interaction with the chromatography paper. Next is a procedure. Okay, the first step of the method is to bend a paper clip so that it is straight with a hook at one end. Push the straight end of the paper clip into the bottom of the rubber stopper. Second, next you hang a thin strip of filter paper on the hook end of the paper clip. Insert the paper strip into the test tube. The paper should not touch the side of the test tube and should almost touch the bottom of the test tube. Okay, third, now you will remove the paper strip from the test tube. Draw a solid 0.5 cm wide band about 2.5 cm from the bottom of the paper using the black felt tip pen. Use a pencil to draw a line across the paper strip 10 cm above the black band. Fourth, pour about 2 ml of water into the test tube. The water will act as a solvent. Put the filter paper back into the test tube with the bottom of the paper in the water and the black band above the water. Fifth, observe what happens as the liquid travels up the paper. Record the change you see. When the solvent has reached the pencil line, remove the paper from the test tube. Measure how far the solvent travels before the strip dries. Okay, finally, let the strip dry on the desk. With the metric ruler, measure the distance from the starting point to the top edge of each color. Record this data in the data table. Calculate a ratio for each color by dividing the distance the color travel by the distance the solvent travel.
My name is Muhammad Syafiq Adli bin Azmi. I'm from group RAS 1153E. This is result experiment. Color of ink listed in order. Yellow, the distance of the solute ink from the baseline is 7.0 cm. Pink is 8.2 cm. Red is 10.1 cm. Purple is 11.0 cm. And blue is 11.1. The distance of solvent travel is constant, which is 11.1 cm. With this information, we can calculate our F value, which is distance traveled by solute in from the baseline divided by distance traveled by solvent from the baseline. For the yellow in, we get 0.63, pink 0.74, red 0.91, purple 0.99, and the blue 1.0. Based on the table result, the distance traveled by solvent from the baseline is 11.1 cm. This is constant in all color in the black ink. For the blue color, only one colored spot was observed, which is blue. The distance traveled by said spot was 11.1 cm, and by using the formula of RF value, 11.1 cm divided with 11.1 cm, the RF value is 0.1. For purple color, had 11.0 cm distance traveled by the spot. respectively. The RF value for the purple spot is 0.99. For the red color, the distance traveled for the red color spot is 10.1 cm. The RF value for the red spot is 0.91 respectively. For the fourth color is pink, the distance traveled by said spot was 8.2 cm and the RF value is 0.74. For the fifth color, which is yellow, only one color was identified, which is yellow color spot. The distance traveled by said spot was 7.0 cm and the RF value is 0.63. The stationary phase of this experiment was filter paper because the filter paper is not going anywhere, while the mobile phase was the water where it will take part of the mixture along with it. The compound of the color spot will either stick with the stationary phase or moving with the mobile phase depending on the force that take place. Black in molecule that are highly charged has more ionic binding, thus making it more polar. This will make the molecule more attracted to the paper more strongly and making it have lower RF value. All yellow color spot have the RF value of 0.63, which has the lowest value of all color spot. This indicates that the yellow pigment has a higher polarity and is less soluble than the other color spot. The intermolecular forces between the yellow pigment and the mobile phase are weak, but instead has a higher bond with the stationary phase. Thus, the absorption is higher and it travels the shortest compared to the other color spot. The intermolecular forces between the yellow pigment and the mobile phase are weak, but instead has a higher bond with the stationary phase. Thus, the absorption is higher and it travels the shortest compared to other color spot. Meanwhile, the blue color spot in the black ink travels the furthest and has the RF value of 1.0. This indicates that the blue pigment has a lower polarity and highly soluble. Inform strong intermolecular forces with the mobile phase, which increase the time for it to be dissolved. Thus, the further the mobile phase will take it. Throughout the experiment, there is several precautions that need to be wary about. One of them when drawing the parallel line in the chromatography, use a good quality pencil so the mark doesn't dissolve in the solvent. Another precaution is the beaker is always kept sealed when the paper is inserted in it to stop the solvent from evaporating. The conclusion is the proposed hypothesis was correct. The paper chromatography did show that the black ink could be separated into various colors. The black ink get its color from a mixture of the various color ink blended together. The first color of ink to appear on the filter paper was yellow, followed by pink, red, purple, then blue. The colors separated the way they did because of the difference in their molecular characteristic, especially their solubility in water and their rate of the absorption by the paper. The most soluble and readily absorbed in the ink color was the yellow. The least soluble and the least absorbable ink color was the blue. This is reference and resources that we use to make this presentation. That's all from me and my friend Faiz. Thank you. See you another time. Assalamualaikum.